Video, we are going to solve another question. We'll apply the concepts that we have learned in motion in one dimension. So let's take the scenario. The scenario is, suppose at moment t is equal to 0, which means that we are starting the stopwatch now, and at this point at this moment t is equal to 0, a particle leaves the origin and moves towards the x-axis. So let's be very specific. It moves towards the positive x-axis, suppose. Well, now it says that its velocity varies with time. That is, there is a direct relation and it varies with time, and this equation is given wherein this velocity v as a function of time is equal to v naught times 1 minus t over tau. So this is given that its velocity varies with time, and that's the function given. Now then it says this velocity vector v naught is the velocity vector of, or it's say, suppose since it's v naught, its initial velocity vector and it should be a constant. Its magnitude is 10 centimeter per second, and the tau in the equation and tau is 5.0 seconds. The tau is a time which is constant there, and that's given 5 seconds. Well, this is the situation, and we need to find here its x coordinate. At moments of time (6, 10, and 20 seconds). So we need to determine what is the x coordinate at those moments of time, 6, 10, and 20 seconds. The next part of the question says, find the moments of time when the particle is at a distance of 10 centimeter from the origin. So it says 10 centimeter from the origin, so it can either go to positive or it can go to negative of the origin. The third part of the question says that find the distance s. And what is this s? this distance s which is covered by the particle during first 4 seconds and 8 seconds. So I think the question is pretty much clear. It's very clear. Let us draw the diagram just to represent what it is saying. So it is saying that we have an origin here and a particle is moving along the x-axis, which is positive x-axis. So this coordinate of this origin is 0, 0. And we need to find what is the x-coordinate at these times. The times are 6, 10, and 20 seconds, the first part of question. So what are the given things? So the given thing is, this is velocity, which is a function of time, is given as v as a function of time is equal to v naught velocity, which is the initial velocity vector, 1 minus t over tau. Okay, so this is given and we need to find x. So it's quite clear that if we know that this x, we know that this x, which is the position vector here in this direction, what would be x? So this is equal to, if you differentiate dx by dt, we get v, right? We get v. Now this implies that dx is v dt, right? So if you want to find x, we need to integrate both sides. So if you integrate both sides, v as a function of time is already given in the question. So from 0 to x, where it is, we'll be able to find, and here from 0 to whatever time is given, we'll be able to integrate, and then we want this value. So this implies that this x is going to be 0 to time t. What is the velocity, which is function of time, dt. If we are able to integrate this, we'll be able to get the value of x. So that is how we will approach this question. Well, so there's no place in the board. I'll rub it and then we'll move. So take down the question and then we'll move ahead with the solution to this problem. All right, so I hope you have taken it down. So the first part, we need to take into consideration the times given in the question, and after we integrate this, we'll put in those limits and we'll get respective x coordinates. So this equation is what's going to be used here. So this x, I'm writing it here, x is equal to integral 0 to t v. Now we know that this is given as this 1 minus t over tau, which is a function of time dt. All right, so everything else is given, and we can safely use this. Modulus is also given. It's a constant value. So we'll take out of the equation and we'll be left with, so this comes out to be, this comes out to be, so if you take out this v. So one more aspect is there. Let us be very clear of certain things. Suppose here we take v as x, and if you multiply this with I cap, this is what is velocity in the x direction, right? The velocity vector in the x direction. Now this is going to give the magnitude of this. So this is what we need to find. So therefore, so this is what in vectors. So we'll write this as, since we are moving in x direction, we can write this v velocity vector is equal to vx, which is the velocity in the direction x. If you multiply this with the I cap, that is what the velocity is given. So this is actually the magnitude of this. and magnitude of this is given as this, right? The magnitude of this, which means that modulus of this times I. So this actually shows that we have here V naught magnitude of this 1 minus T over tau I cap. So this part is the magnitude that we have multiplied with a unit vector to get this. So just a brief information that we understand this, how it moves further, and then we'll use this equation there instead of this, since we want the magnitude. So this is what we want. So therefore this x is equal to, we'll take this magnitude of the velocity, initial velocity vector out, and we are going to integrate this from 0 to t, that is 1 minus t over tau dt. Okay, so if you evaluate this, so this comes out to be, this is going to be t, so it's just here, you take this as common, inside it it's going to be dt here, just so the integral of that is t, and we can write this t here, and this minus t is there, and 1 over tau, this tau is also constant, so we can take it out, so it will be 1 by tau out, and when we integrate t, it will be t square by 2, so we'll take 2t out, and then we apply the integral sign, so here we'll have t0, so it's just t, and here we'll apply the limits here, it's going to be under the bracket t square. This is what we get finally. So if you take t out from here, so this is what we get as final expression. So this we are getting modulus of v naught times t. If you take this out, it will be 1 minus 1, or say it will be t just remaining 2 tau. So we got x as a function of time. So here we can write this x now we got as a function of time. So once we'll put 6 here, if you remember, and then the next part was 10 seconds and next part was 20 seconds. So take down this, and then we'll put in these values here to find what is the x coordinate corresponding to those times given in the question. So at t is equal to 6 seconds, x 6 is equal to, magnitude of this was given 10 centimeter per second, and time is seconds, so seconds cancel, so this is centimeter, 10, and this multiplied by 10 into 6, and then 1 minus, time was 6, 2, and tau was given 5, so we can multiply here 5. So it comes out to be 10. 10 minus 6 is 4. 4 divided by, so this comes out to be 60. 60 times 4 divided by 10, which comes out to be, so this comes out to be 24 centimeter. So 24 centimeter is the x coordinate, which is at 6 seconds, that is what we get, 24 centimeter. Then at t is equal to 10 seconds, so we'll put x 10, so this comes out to be 10 times 10, and it's 1 minus 10 divided by 10. So this goes 0, so which is equal to 0 at origin. X is origin. All right. At t is equal to 20 seconds, we get x 20 is equal to 10 times 20, 1 minus 20 over 10. and this comes out to be negative here. So 2 divided by 10, 2 divided by 1, so it's 20 divided by 10, which is 1 minus 2. So this comes out to be 200, and it comes out to be minus 200 centimeter. So this is going the other side of the origin, which is 20 times 10 is 200, and this here 1 minus 2 is minus 1, so it comes out to be minus 200 centimeters. So that is how we apply calculus to get this answer. So that was first part of the question. Take down the steps and then we'll move forward with the second part. In the second part it says, we need to find, say, what are those times wherein that particle is at 10 centimeter from the origin. So from origin it can go either ways, positive and negative. So we'll put those values there and then we will get. So we already actually know this, right? We know this what it is, x as a function of time. So we'll be using this equation in the second part of the question, and then we'll find out the times there. Well, so let me drop this part of the board. So in the second part of the question, was the moments of time when the particle is at a distance of 10 centimeter from origin. So if you remember, this was the case. So using this equation, so we can write it here. We have already derived this equation, that is x as a function of time, and this is magnitude of v naught, which is 10 times the t. In the bracket we have 1 minus t over twice of tau. This is what we have. Now this is given. So therefore, at x is equal to plus 10 centimeter we'll find, and x is equal to minus 10 centimeter we'll find, and then we'll put in, and then we'll make subject of equations here, time t, and then we'll find. So if you at 10 centimeter, if you substitute that value, so we'll get 10 is equal to 10 times t, and here we'll have 1 minus t by 2 tau, and tau we already know, which is 10. So this is tau was 5 given in the equation, if you remember, tau 5 seconds, and this velocity vector was given 10. Well, so we get a quadratic here, so 5 times 2, which is 10 here, 10. Well, if you take the LCM and you move forward with it, so you'll get a quadratic here, right? So if you open the bracket and put it here, so it comes out to be 10 t. In the bracket it comes out to be 10 minus t over 10. So this 10 gets cancelled, so this comes out to be 10t minus t squared. So 10t minus t squared is going to be 10 here that we get, and we can solve this equation for t. It's a quadratic equation. So let's solve this and try to find what we get. So at 10 centimeter, we get this equation, which is, so you can bring all those variables here to the right hand side and write it. So we are getting t squared minus 10t plus 10. Well, this equates to 0. So therefore, we can use directly the formula. Therefore, this t will be equal to 10 plus minus under root b squared, which is 100, minus 40, divided by twice of a, which is 2. So this comes out to be 10 plus minus under root b square minus 4ac. We have used the formula directly, and this comes out to be 10 plus minus under root, it comes out to be 60 divided by 2. So can we take 2 out? Yeah, we can take out. So this comes out to be 15 times 4, so which is 10 plus minus under root. It comes out to be 15 times 4, so we can take 15 here and take 4 out, which means 2 would be out. So 2 would be out here, and here will be 2. So if you take 2 common, therefore t becomes, so if you take 2 common, it would be 5 plus minus under root 15. And this 2 gets cancelled. So this is what we get, 5 plus minus 15 under root. So 15 is going to be less than 5, right? Root of 15, square root of 15 is less than 5. So both would work, plus and minus. So the time comes this. Well, so if you take at 10 minus 10 centimeter, right? So if you take in the other side the negative direction of the x-axis, and we put in the same values there, let's try to find what the equation says now, or what value we get for the time. So we get minus 10. Putting the same in equation there, so we had this v naught t, which was 10t, and in the bracket we had 1 minus t by twice of tau. Okay, so we get here minus 10 is equal to, now we get for this, so we need to take into account this, and this is tau is 5, so this will become 10, and this becomes 10t times 10 minus t, and here it becomes 10, so this gets cancelled, and we get here 10t minus t squared. So just that sign has a different this thing, so we'll bring it that t squared this side, so we'll get t squared minus 10t, and then minus 10 is there, is equal to 0. Well, again, so therefore if you use the formula, therefore this t would be 10 plus minus under root. Now here it's quite interesting. So this is going to be 100 minus 4ac, that is 40, but it is minus, so minus and minus, right, becomes plus, so this would be plus 40 divided by 2. So this comes out to be 140. So this comes out to be 10 plus minus 140 divided by 2. Can we take that out? Yeah, we can. So this is 70 if you divide by, if you multiply it by 70 times 2, or say 4 if you divide 4 3 12:45. So this comes out to be 4:3. So 35. I'm just writing it here. So I'm just writing this one here. So we can write this, therefore t is 10 plus minus, we can write 140. If you want to divide by 4, so it comes out to be 4 3 times 12 and 5, 35 times 4, and this divided by 2. So therefore this t becomes, so 4 you take out, so it is 10 plus minus 2 under root 35 over 2. Now you take this, so we'll get 5 plus minus under root 35. Now 5 times 5 is 25. So this one would be more than 5, right? If it is more than 5, the square root of this is going to be more than 5 and less than 6, which means that if you want to use the sign here, we cannot use the negative sign. Why? The time would become negative then. So therefore time would just be taking the positive values, so it should be just 5 plus 35 seconds. So if you take this negative, the time would become negative, so we can't use that, so we'll just be using the positive, and therefore we get this time for when x is equal to minus 10, and we got there when x was 10, we got the two values here. So one was 10 plus we got root 15 10 here we can have this here plus minus both. So therefore we can have both values, that is t could be either in this case 5 plus under root 15, or t could be 5 minus under root 15 seconds. However, here we'll just have 5 plus 35 because we cannot take negative here. The negative would cause the time to go negative, which is not possible. Well, so these are the calculations. You can take note of it, try to work it out, and try to understand how we got those answers. Okay. Now if you remember, the last part of the question says that we need to find the total distance s during the time, and the time was given 4 and 8 seconds, if you remember. So let's try the last part of the question, which says that what is the total distance covered when the particle moves from start at first 4 seconds and 8 seconds. So how do we use that equation that we have velocity with the function of time, right? Or that you need to find the distance. So find the distance or the total distance s. So this distance is covered by the particle during next or first or during first. So it was actually during first 4 seconds. So first 4 seconds and 8 seconds. So we need to be careful that this 4 seconds and 8 seconds, and we should keep in mind the equations. So what are the equations we had? We had this equation, this x as a function of time, the position as a function of time. We got this as equal to integral 0 to t vx dt. Okay, and this vx was given v naught 1 minus t over tau. This was Vx given, the magnitude of this, so it was proceeding along the x-axis positive. Now if this t is less than equal to tau, and we know for tau, given in the question, the tau is 5 seconds, right? So if it is less than 5 seconds, which is 4, so for this we can use this equation. So therefore, let S1 be the distance covered. So it's a continuous distance covered, therefore we'll from 0 to t, and now we'll put the value of 4 seconds here. So therefore S1 be the distance covered. This implies that S1 is going to be equal to, we'll take v naught out, which is 10, we'll take out and we'll integrate from 0 to 4, and we'll use this equation, which is 1 minus t over tau, which is t over 10, no, 5, right? It's given 5 dt. All right, so if you evaluate this, let's see what it comes out to be. So it comes out to be 10. When you integrate this, this would become t, and when you replace this, it's going to be 4 minus 0, no problem, and this would be minus, and this would become t squared by 2. So if you integrate t by 5, it would become t squared by 2. So if you take 2 out, this 5 is also there, so it would be 5 times 2, you can put a bracket here, minus, now we'll be getting t squared, and when you put the limit, so this would become t squared, which is 16. Well, this is what we get. So therefore S1 is going to be 10, 4 minus 1 over 10 into 16. So this comes out to be 40 minus 16, which is 4, and so 10 would get cancelled, so it comes out to be 24, right? So it is 40 minus 16 is 10 minus 6, 4, and here it becomes 3 minus 1, 2, which is 24, divided by 10 and multiplied by 10, so this would get cancelled, and we'll get 24 centimeter when you integrate with the limit 0 to 4 seconds. So this is what we got as an answer for the first part of this. Then we'll check for the 8 seconds. So for 8 seconds, we need to be careful that this 8 is more than the constant there, which is 5 seconds. So we'll use that same logic, that where it's going to be negative, where it's going to be positive, and then we integrate. Well, take this down, and then we'll move on to integrate when we have a limit from 0 to 8 seconds. Okay, so let's proceed. So we find that this Vx is this when this is less than tau. What would be Vx? What's going to be this Vx? Vx would become V naught, and it would become, if this is 5, right, and if t is for 8 seconds, that is, we can write for some time which is more than tau, which means that which is more than 5 seconds, right? If it is more than 5 seconds, then this in the bracket it's going to be negative, because 5 minus the larger number, so it's going to be negative. So if you pull out the negative one, whatever answer comes, it will be negative. So if you again so let's put it, no problem. So it is t by 5. Well, so this is for time more than 5 seconds, this function. So if you open the bracket, so this would become v naught, so Vx would become v naught t. If you open the bracket, minus and minus would become plus, t over 5 minus 1. This is going to be the function of time, the velocity as the function of time when you get a situation that is for t more than 5 seconds, which is 8 seconds. Why we are concerned? Because 8 is more than 5. So therefore let S2 be the distance covered during first 8 seconds. If this is so, therefore S2 would become integral. Now 0 to 5 would be less than, so we'll use this equation. So for 0 to 5 we'll use this equation, which will be, we'll take V0 out and then we'll put in here 1 minus t by tau dt. This 0 to 5 plus more than 5, so it would be 5 to 8. We'll have to use this equation. So it would be, again, we'll take V0 out of that integral and thus we'll just be left out with t by 5 minus 1 dt. So it's going to be the summation of these two to find this. Well, now let's evaluate this. So we know this V0 to be 10, so we'll replace this by 10. Here also we'll replace this by 10. We'll replace tau by 5 in the equation, and then now we'll integrate. So if you integrate this dt, and this would become t, and if you just evaluate, so S2 is going to be 10 times the first part. If you are going to consider, this would become t, and 5, if you replace, it's going to be just 5 minus 0, and this will be minus 5. Now t by 5, if you integrate this, it's going to be t squared by 2. 1 by 5 is already there, so it's going to be 1 by 5 times 2 would be out, and in the bracket it will be t squared. So here it's going to be 25. Now it's going to be 25. Well, this is what we get for the first one, and 10 is out. Okay, plus here 10 is again out, so let's put it out, put a square bracket. Now here it's coming out to be t squared by 2. Now 5 is already there, so we'll pull it out. So 5 times 2, and this becomes t squared, which is going to be, if you pull in 8 here, it's going to be 64. It's going to be 64 minus 5 squared, so it will be 25 actually. So 64 minus 25. Well, for this one, first part, and then minus, this is going to be just t, which is 8 minus 5. All right, so this is how we integrated that expression and put in all the values we'll be getting. So 64 minus 25, it comes out to be 1, and 6 minus 2 is 4, which is 41, and here it comes out to be 8 minus 5, which is 3. So 41 minus 3. So one more thing is there. Okay, yeah, 5 by 2. Here it is 10. All right. So it's going to be quite interesting that this t squared is 64 minus 25 is coming out here for this 5 to 8, for more than 8, and here it comes out to be 5 minus this. So let's evaluate this. So we'll come out to be here, it's coming out to be 64 minus 25, it is 9, and 5 minus 39, sorry, it comes out to be 1 over 10. So from here, so it is 10 into, it is 25 by 10, so it comes out to be 50 minus 25. So 25 by, it's 10 times 5, 50. 50 minus 25 is 25, so it would be 25 here divided by 10. So this is just 25 plus Well, let's come to here. 64 minus 25, sorry, so it comes out to be 30. 14 minus 5 is 9, and here 5 minus 2 is 3, so it comes out to be 10 into 10 here under the bracket, and it comes out to be 39 divided by 10 here, and here it comes out to be 8 minus 5, which is 30, so minus 30, so it would be, if you take the LCM, it would be 10 minus 30. Well, okay, so we have already taken into account this 10, and 10 would get cancelled here. 39 minus 30 is 9, and here it is 25, so this comes out to be 25 plus, so this is 25 plus 9, so this comes out to be 34 centimeter. So if you evaluate this and solve this, it comes out to be 34 centimeter. So for this one we get S2 as 34 centimeter, and for here we got here, I remember it was around 24 centimeter. So that is how we evaluate this, and we have completed the calculation, and we have seen how it flows and how we need to be careful about which function to use when we are dealing with calculus integration. Well, so I'll write the answer here. So this answer we are getting, the distance for this one is, so the distances we are getting for this one is 34 centimeter. That is what we are getting here. Well, take it down, and then in the next class we'll move ahead with the next topic. Thank you.